All right, what we're going to talk about here is how to construct a one sample t interval, all right, for means. All right, for means. And this is just very similar as one sample z interval for p. It has a four-step process. We have our state our parameter, all right, our true mean, all right, of our population at whatever confidence level we want, all right, along with the confidence level. We want to have a one sample t interval for mean, all right. We then want to make sure that we have the conditions, all right, conditions for normal conditions. And when we have this, our conditions also, we want to make sure that we can use randomness. Okay, we have randomness. It's random, all right, 10%, and all those kind of things. And then the condition for normal, we want to make sure we have that as well. Okay, and so of these different things for the condition normal, the one difference here for the condition normal is that our population, what we look for when we have means, if you recall, is that population is normal for means if it says the pop is normal. Also, we can use the central limit theorem if our n value is greater than or equal to 30. That's another cool one. Or if none of these work out, we aren't given that, we can actually graph out the data. And if our sample shows that there are no strong skews or outliers, then we can also just assume that it's going to be normal. From here, we're going to figure out a confidence interval by using our critical value, which is going to be a t value, not a z. And also, we're going to use our approximated standard deviation, all right, our sample standard deviation, because we do not know what the actual standard deviation is. If we did know that, we could use our z interval, but because we do not know it, and we're going to just use our sample, which is most generally the time, is that we're going to use our sample standard deviation divided by the square root of n. We then make our conclusion, all right, like we normally do. Okay. Now, for our sample size, as we know, our margin of error, this is known as our margin of error, is that our t value is our critical value, or our t value, we can find. Also, what we use is this value right there. This is known as our standard error. Okay, standard error. When we have for means. Now, if we don't know our t value, okay, because we do not have an n that we know, well, that's going to be kind of hard. So if we do not know, if t is not known, then we can use a z in its place if that were the case. So once again, the conditions for doing this: random, 10% normal, okay, and critical value, we need to use what's known as degree of freedoms when we're using our t values. Now, where does this table come from? Well, we use a table B. We can also use our calculators. We can use inverse t, all right, inverse t, where we take our 1 minus our percentage divided by 2, and then we have our degrees of freedom. Degrees of freedom, once again, is whatever n value minus 1. We always want to round down for degrees of freedom if it's not on our table. So for example, if we have an n of 40, okay, sometimes we don't have n of 40 on our table, we would round it down to probably an n of 30. Okay, and so if you're wondering what a degrees of freedom looks like, this is a t distribution, also known as a student's t distribution. It's very similar to a z distribution, however, it is wider. It is wider because we're using sample standard deviations in order to create our values. And the larger our n values, the closer it is to an actual z distribution. Okay, so when we have n values that are smaller than 30, becomes very, very wide, and that means our margin of error becomes longer. And so you can see this right here. So you can see the standard deviation right there for a normal distribution, and a t distribution is wider. And is all predicated upon what the n value is, and that's where we get our degrees of freedom. And so you can see this is what we have for our table. You can find this in most calc books. You can also Google it. All right. And that's where I got this one as a Google. And you have your degrees of freedom here, and then you have your various values, all right, for your area. Our areas that we find, okay, for our t value is going to be to the right side, unlike when we do the other ones where we have a z, which is always percentiles to the left. Okay, and so using this, we're going to start with our next video. And so going through here real quick, Once again, 4-step process to find one sample t interval. These are the notes, and we're going to go through using these notes, all right, in our next video.